Welcome everybody, my name is Mehmet, and in this short video I'm going to talk about why BGP is more scalable than RIP, EIGRP and OSPF, which are collectively called IGPs. But first I'll start with a very common question asked by many learners who are new to BGP. The question is this: why don't we use IGPs, right? Because BGP is more scalable is the answer you might have been given with no further explanation. But to me, the answer itself leads to more questions. For example, what do you mean by scalable? And the second question, and which I believe is more important than the first one, what makes it or what makes BGP more scalable? The simplest definition of the word scale would mean to grow or expand in this context, meaning you could have far more routing entries in your BGP table or routing table. This is clear. But what is not clear to me is that what makes it more scalable. I mean, why does it have more routing entries? Or why is it more scalable? Is it because as soon as you configure BGP, more system resources are allocated to BGP? Or is there a certain limit on the number of routing entries for IGPs? No, my friend. So please notice the keyword more here as it is in this example. It says she is more beautiful. See, the keyword more implies that we are comparing things, right? It indicates that we are comparing things. Basically, we are comparing elements of beauty here, which might be height, weight, and etc. Likewise, when I say BGP is more scalable, what elements do you think we are comparing to reach this conclusion? So we need to find out the elements we are comparing so that we can truly understand what the sentence is saying, right? And fundamentally, it all boils down to two elements when we talk about routing protocols. How they choose their best path to a destination and how they prevent loops. These are two fundamental elements. Now let's take BGP and EIGRP for example. Here's a router in which there's a guy, his name is EIGRP, and he has given two paths to a destination, destination X. He is to decide, he is to choose one of them. Do you recall the formula? This is the formula. Minimum throughput plus total latency. To find or to calculate this, you have to do, to find out minimum throughput, you use the first one, 65536 times 10 to the 7th divided by minimum bandwidth. And for total latency, it's 65536 times total delay divided by 10 to the 6th. See, this is how scary it is, right? You have to use, EIGRP has to use this formula for each and every path. For the time being, he has two paths to the same destination. Just imagine that I give him 10 different destinations with multiple paths. How about this one? If I give him 500,000 different paths different destinations with multiple paths, what do you think will happen? This guy will start crying. What about BGP? Do you remember how BGP selects its best path? So there's a list of attributes in a specific order, and BGP starts with the first attribute. If it's a tie, then he moves down to the next attribute until he finds a tiebreaker. How simpler could it be? See, even if BGP is given, BGP is given a million routes, he will continue. Okay, definitely it will slow him down, but there will be no tears. And one more thing, EIGRP has to do this calculation so fast that there will be almost no delay. Even if he pauses longer than expected, do you remember what will happen? He'll be receiving SIA messages, right? So as for how they prevent loops, this is the feasible condition is what EIGRP uses to find a loop-free path. For example, feasible successors, FDs, RDs, and all other things that he has to take into consideration to find a path which is loop-free. Imagine he's given 500,000 route. See. And what about BGP? Do you remember how BGP finds a loop-free path? See, I mean, if I see my own AS number in the AS path attribute, I will simply discard it. Can you see how simple it is? So that's why he can handle 1 million root entries. To sum it up, it is the simplicity in path selection and loop prevention which makes BGP more scalable. Thanks for watching, and if you have any questions, you can leave a comment.